In this example, we've got a dragster that's been stripped down so that it has no speedometer. And we're told that at maximum acceleration from rest, it travels 150 meters in 10 seconds. And we want to know what speed did it reach after those 10 seconds. Well, let's take a look at the velocity curve for this dragster. Okay, so I'm going to just draw a graph of velocity over time. Now we have to assume that the acceleration is constant, right? So they on the gas and this dragster accelerates at constant acceleration. So if it's accelerating at a constant rate, then we're going to get a nice linear function for velocity, right? And so we're starting at rest, and so we're going to start here at 0, 0. At time t equals 0, we're at 0 meters per second. And then our velocity will just steadily increase over time. All right, if we're assuming constant acceleration. So, and then we're told, okay, down here at t equals 10 seconds, we traveled 150 meters. All right, so what we're being told there is the area. We're being told that the area under this curve is 150 meters, right? Because we've determined that the distance or the displacement is the area under the velocity curve. And what we want to know is what is this final velocity here? All right. So we can solve this very easily just by recognizing that the area under the velocity curve is just a triangle. All right. The base of the triangle is 10 seconds wide, right? This base is 10 seconds. And the height of this triangle is whatever our final velocity is. We don't know it. That's what we're trying to find, but we know that the area is 150. All right, so we can say that the area, which is our distance, is 150, and that has to be equal to 1/2 base times height. In this case, our base is 10 seconds, and our height is the velocity that we're trying to find, our final velocity. All right, so all we really need to do then is solve this for the final velocity. So if you basically, this is 1/2 of 10 is 5, so just divide both sides by 5, and you find that the final velocity has to be 30 meters per second. And we know it's in meters per second because our distance was in meters and our time was in seconds. Okay? That's all there is to it. This idea of the area under the velocity curve is very powerful.